All right, here's another problem from 11.1. We have 6 people arrange themselves randomly in 6 consecutive seats in a row. We want to do two things here: determine the number of ways in which the described event can occur, and determine the probability of the event. So these are actually, if we're going to determine the probability of the event, we're going to have to determine part A anyways. They're actually just having us do that in two separate steps, actually really not necessary. So anyways, for 61, the situation is each man sits immediately to the left of his wife. So we've got 6 people. We're assuming that's 3 married couples. And so if we gave ourselves 6 slots here to think about this, if we think about how we place the husbands, then there's 3 ways to place the initial husband. And what's going to go next to that husband is his wife, and there's only one choice on that. And then we have 2 other ways to place the next husband. And again, the wife will be sitting next to him, so only one way to choose that. And then there's only one way to place the remaining couple. Okay, so I should say this is part A. So this is the desired situation if we're looking at this scenario. So there's actually 6 different ways that each man sits immediately to the left of his wife when you're actually doing this situation. If we wanted to talk about the probability, that's part B of this problem, so the probability of this event would be the desired outcome, which is 6, we've already calculated, over the total number of possible outcomes. And the total number of possible outcomes here is basically in how many ways can we place 6 people in a seating arrangement like this. And that would be 6 factorial, because you would have 6 ways to place the first person, 5, 4, and so on. And there's no restrictions. I probably shouldn't, that looks like fractions. I shouldn't have done that. Anyways, what was I going to say? Oh, there's no restrictions on this 6 factorial. The reason that we counted the top the way that we did was because they gave us a specific scenario that presented some restrictions. So we had to think about that. But the bottom is just how can you place these 6 people? In the first slot you have 6 choices, second slot 5, 4, 3, 2, 1, and so on. Okay. So anyways, if you simplify this, 6 factorial I believe is 720. So you would get 6 over 720, and then when you reduce that, this would be 1 over 120. Okay. All right, so that is number 61. Number 63 deals with the same problem, the same setup, and just has a different restrictions that it's asking about. So let's take a look at that as well. So this is number 63. So the situation is the same. We have 6 people arranging themselves randomly in 6 consecutive seats in a row, and we want to know basically the probability that the women will be in 3 adjacent seats. Okay, so let's go ahead and calculate, first of all, that situation right there. So we've got 6 seats again. Now, the restriction in this problem is we want all of the women in adjacent seats. So let's count that first. So we could have the women sit like this, and they could also sit like this, and they could also sit like that, and we just keep counting this, and then like that. Okay, so there's actually 4 ways that the women can place themselves in adjacent seats. Now, we also have to consider that within this 4, there's an iteration of 3 factorial, because there's 3 ways to place this woman, and 2 ways to place this woman, and then 1 way to place that woman amongst their grouping as they move around. So we would have to multiply this by by a 3 factorial. And then we also want to think about how we place the men, because that's the other thing that we need to count. So the other thing counting the men is the same way that we counted the women. So we have 3 men to place in this position. So there's 3 choices here, 2 choices there, and 1 choice there. So we have to multiply by another 3 factorial here. Okay, so this piece is counting the women, and this piece is counting the men. All right, so that is the answer for part A there. And then part B is asking us for the probability, which means that we are then just trying to find the total because this is the desired for this particular situation. Okay, so so the desired here, probability of this event, is going to be this, and that number is 144 if you multiply that out. So it's basically 4 times 6 times 6. So you get 144. So that's our top. And then in the bottom, again, we want to just decide, you know, how do we place 6 people? It's the same as number 61. It's 6 factorial. So we have 144 over 720, and that will reduce down to a 1/5. And that's it in those problems.